Yes.
Okay, first thing we're going to look for is the domain. Somebody remind me, please, how do we find the domain of a rational function?
Set the denominator not equal to 0.
Very good. Good job. So I'm going to say x squared minus 9 cannot be 0. All right, you can either factor this into x plus 3x minus 3, or you can just solve it. When I move 9 to the other side and I take the square root, I get x cannot be plus or minus 3. Do you guys agree with me on that?
Yes.
Okay, so how do I say x can be anything in the entire world except for positive and negative 3?
Domain is negative infinity to negative 3.
Negative infinity to negative 3. Does it include negative 3?
No.
Nope, so we use a parenthesis. Union, keep going.
Negative 3 and 3.
Negative 3 to positive 3. Why did I write that? Negative 3 to positive 3. Union, what?
And then 3 to infinity.
Perfect. Who was doing that with me in here? Good job. Good job, good job, good job. All right, now I've told you guys before, vertical asymptotes go hand in hand with domain. So when you're showing me your work, because you guys want to do everything you can to show me all of your thinking, your vertical asymptote goes hand in hand with your domain. Those two vertical lines that your functions are going to get really, really close to but not exist at would be x equals what?
X equals positive 3 and negative 3.
Positive 3 and negative 3. Ladies and gents, I cannot express to you enough, when you write your vertical asymptote, it needs to say x equals negative 3 and x equals positive 3. If you just tell me 3 and negative 3, I'm marking it wrong. There's a huge difference between a vertical asymptote and a horizontal asymptote. Different letters. You guys need to make sure that you denote that to me, please. All right, next thing we're going to talk about is our horizontal asymptotes. Okay, this is how you would show me your work for your horizontal asymptote. We compare the numerator and the denominator degrees, correct?
Yes.
What's the degree of the numerator? 2. Good. What's the degree of the denominator? 2.
Also 2.
What do we know about 2 and 2?
2. They're the same.
They're the same. They equal each other. That does not mean your horizontal asymptote is at 2. You take the leading coefficient of the numerator, which is 1, over the leading coefficient of the denominator. So I have a horizontal asymptote at y equals 1. Questions?
No.
Y equals 1. X and Y. You've got to have those, please. All right, for slant asymptote, I don't mind if you just look at it and tell me, yes, there is one, no, there's not. Is there a slant asymptote in this function?
No.
Why not?
Because the numerator degree equals the denominator degree. It's not above it.
Good, Vincent. If the numerator degree is higher than the denominator degree, then you will have a slant asymptote. In this case, there's not. For those of you who don't understand that or just see that, okay, right, we're going to write none for horizontal or for slant. But for those of you who don't see that, I'm going to do a little work up here. Remember, your slant asymptote is going to be in the form of y equals mx plus b, right? That's the equation of a line. So if I said, well, let me check. Let me use my long division. And I said x squared minus 9 divided into x squared minus 4, or x squared minus 4 divided by x squared minus 9. If I use my long division here, first term into first term, x squared times what gives me x squared? 1. Guys, this line that you just created was y equals 1. What is y equals 1?
A horizontal asymptote.
It's our horizontal asymptote. A slant asymptote is a slanted line. It's not going to be a horizontal or vertical line. So mathematically, if you try and work that out, when you do and the degrees are the same, you'll just get the horizontal asymptote. But I'm fine with you just looking at it and saying, oh, there's none. I don't need to see the long division work. All right, moving along. How would I find the X-Intercepts?
Set the numerator equal to 0.
X-Intercept. Good job, Carlos.
Oh, Miss Meadows?
What's up?
What if the numerator is... Sorry, what if the denominator for slant asymptotes is bigger than the numerator?
You won't have one.
Can you add placeholders to the denominator?
You can add placeholders, but you're looking at the degree, the highest degree. The only time you have a slant is when the numerator degree is higher than the denominator. Just give me a second. We'll do one in a second, all right? All right, remind me again about X-intercepts. Numerator equal to 0?
Yep. Numerator equals
So guys, I have x equals plus minus what?
4.
Nope.
Oh, sorry, 2.
There you go. If you want to work it out, that's fine. I understand most of us in here can do that. If you want to factor it out, x minus 2x plus 2, then solve each. Or if you want to move 4 over, take the square root, it's fine. But you have X-intercepts at positive and negative. I want them written as ordered pairs. So it's going to be negative 2, comma 0, 2, comma 0. On your test, next to the line that says X-intercept, I wrote the words ordered pair. So I want the answer in a what? Ordered pair. Okay, good. How do we find the Y-intercept, ladies and gents? Remind me how to find Y.
0 for x.
Plug in, you're going to evaluate f of 0. F of 0. So we're going to plug in zeros everywhere we see an x. So I have 0 squared minus 4 over 0 squared minus 9. So what does that leave me with? Negative
4 over negative
4
9.
over negative 9, which is
4 over 9.
4 over 9. So I have a Y-intercept as an order. Come on.
Like a little bit under half.
Correct. So it's x is 0, y is 4/9. All right, what's the last thing I need to check for? Holes.
Holes.
How do we find holes?
Oh, you factor the numerator and the denominator.
There you
See if
go.
anything.
Numerator and denominator. So I have x minus 2, x plus 2 on the top. What about the bottom?
X minus 3, x plus 3.
Perfect. Now, what is going to designate that there's a hole?
If something repeats and it's like the exact same.
Common factors on top and bottom. We cross them out, set them equal to 0. Does that occur here? No. So
No.
you're telling me no holes. Now, was that unbelievably difficult, guys? No.
No.
If you're sitting here watching Netflix or playing a game, and then you get in here on Thursday and you're like, guys, it's so hard. That's totally on you. Like 9,000% on you. Some of you just were like, whoops, she's talking to me. It's okay. All right, so now, guys, let's go through the graphing part. Okay, first of all, I think you guys should commend me. I think this is the neatest work I've ever done on any of these problems, so you're welcome. Trying to be a big girl. All right, let's put our asymptotes on. Let's plot some X and Y intercepts, and let's get the graph looking like it should. I have a horizontal asymptote at what?
At y equals 1.
Y equals 1. So let's plot that. Doesn't matter which one you do first. So y equals 1. Remember, it's a dashed line. Values do not exist there, so we don't draw a solid line. Then my verticals are at -3 and +3, right?
Yes.
Okay, so make sure you count correctly. That's here.
Wait, don't you mean? Oh yeah.
Keep checking me, Carlos. You know I make lots of silly mistakes. That's good. Keep me on my toes. All right, let's plot our intercepts. -2 and +2, 0. So -2, 0, +2, 0. What was our Y-intercept?
It's like a little under half.
Okay, so in between 0 and 1. Well, doesn't this work out beautifully? Because the middle section is always the part that gives us the trouble, trying to figure out whether I have a parabola or a snake. By finding my intercepts, what did I show myself here? There's a parabola in the middle. So guys, I'm telling you, when you draw this, all right, we're looking for end behaviors. I want you to go through the intercepts if you have them. You should get close to your asymptotes, but what? Don't touch them. Okay? Don't be sloppy, because I'll take points off. If you're drawing arrows that go through the asymptotes, that's an issue. Take your time. All right, now how do I find points to the left and to the right of the vertical asymptotes? What do I do?
You plug the x values into
Okay,
the
let's pick
equation.
x values. I want one x value. I don't care which one you choose, but I want an x value that is to the left of my vertical asymptote.
-5.
Okay. So when I plug in -5, I'm looking for a value of y. What is the value of y? What am I really looking for? If it's where? Above or below the horizontal asymptote. I don't need specifics. We don't need specifics. We need to know if we're above or below the horizontal asymptote. So when I plug in -5, f of -5. What's my function again? Okay, so -5 squared minus 4.
Yes.
And then -5 squared minus 9.
Yes.
Okay. So 25 minus 4 over 25 minus 9. What's 25 minus 4, please?
21.
21. And what's 21? What's 25? What's 25 minus 9?
16.
16. All right. Well, 21 over 16. Some of you are like, how am I supposed to put that on a graph? Guys, is 21 over 16 bigger or smaller than 1?
It's
bigger. So no, I know that this part of my rational graph, we'll call it our boom. All right, I know that my boomerang is going to exist up here. Agree with me? Yes or no?
Yes.
Yes. So now I'm going to find out what the picture looks like on the other side of my asymptote.
So, since the x's are squared, wouldn't it be like the same thing? Would it also be above?
It's good thinking. It's very good thinking. Let's just make sure. I like the way you said that. So let's do +5. Someone here said let's do +5. Good thinking though. So I have 5 squared minus 4 over 5 squared minus 9. 25 minus 4, 25 minus 9. 21 over 16 again. So when I plug in 5, I get 21 over 16. So when I come over here and I go to 5, is that above or below your asymptote? It's above. So I'm just going to draw general area. I need you to stay close to the asymptotes for me. My graph looks something like this. All right, let's look at number 5. Somebody asked me before, oh my gosh, are they all going to be the exact same? Obviously not, guys. Some are going to have slant asymptotes. Some aren't going to have slant asymptotes. Some will have holes. Some won't. You have to be well versed in how to find everything. So the first thing I always tell you to find is our domain. Remind me again how to find domain. Denominator not equal to 0. I love when you guys answer me like I'm so annoying. Denominator not equal to 0. Good. That means you're over it and you already know how to do it, and I love it. So.
Miss Meadows.
Yes, sir. I'm listening, Carlos.
So we're going to do the second one?
No. We're going to do the third one now for now.
Oh.
Okay, so guys, what you're telling me right here is that x can be anything in the world except for one number. So how do I write that in interval notation? Negative infinity. Whoa, hold on, my infinity got crazy. Negative infinity to -3.
Union.
Good. And I have parentheses on -3. Why are there parentheses on -3? Does not include.
Because it's not included.
Good. All right, I forget what colors I did, so we'll change it up. Domain goes hand in hand with our vertical asymptote. So you have one vertical asymptote, ladies and gents, where?
-3.
At x equals -3. So you're going to write x equals -3. My horizontal asymptote is when I compare degrees. Numerator degree and the denominator. This is my horizontal asymptote. What's the degree of the numerator? 2. What's the degree of the denominator? 1. So I would say my inequality statement 2 is greater than 1. So what does that tell me about my horizontal asymptote?
No.
There's none. Good, Carlos. I like the enthusiasm. There's no horizontal asymptote. And then Vincent told us, well, then that means there's going to be a what? A slant. Good. So my horizontal asymptote is none, not
so
1.
When there's no horizontal, there's the slant?
Yes.
Okay.
So let's find the slant asymptote. Remember how we do that again?
Long division.
Long division. X plus 3 is on the outside. X squared plus 5x plus 8 is on the inside. You guys love to do long division. I know. Let's get this party started. X times what gives me x squared? X, good. So we're going to put that right above our 5x. Before we get our multiplication going, get your subtraction set up so we can distribute that negative. X times x is x squared. X times 3 is plus 3x. I have to distribute. So 5 minus 3 is 2x. I'm going to bring down that 8. And my x's cancel out. So same thing, guys. First term into first term. X times what gives me 2x? Positive 2 plus 2. Before I do anything here, I'm just going to put my 2x, so, and then plus 6. Do I have to go any further? No.
No.
My slant asymptote should be written in y equals mx plus b form. So you would tell me you have a slant asymptote at y equals x plus 2. Questions?
No.
Okay. Oh, I didn't want to use that color. So y equals x plus 2. All right, you guys doing great. Let's talk about our X-Intercepts.
You have to use the quadratic formula for that, I think.
Vincent, you're spoiling all of the fun. X-Intercepts. How do I find the X-Intercepts? Set what? Numerator equal to 0. Okay, I promise you I will not give you one of these on the test for time purposes. But I wanted to bring this to your attention just to show you. Can I factor this? Are there factors of 8 that'll multiply to give me 8 but add to give me 5? No. So real quick, we're going to do our quadratic formula. Negative 5 plus or minus 5 squared minus 4 times 1 times 8 all over 2 times 1. Negative 5 plus or minus 25 minus 32 over 2. I'm going quickly because I just want you guys to see something. At this point, what can you tell me about my Y-intercepts?
It's imaginary.
How do you know that?
Because there's a negative under the radical.
Because there's a negative underneath the radical. Guys, if there is a negative underneath the radical, if I have an imaginary number, where does the graph cross the x-axis?
It doesn't.
It does not. You don't have any X-intercepts. So you would answer that question down here as none. Now let's
Then
talk.
we can't make it imaginary.
You can't graph imaginary numbers on a regular coordinate plane. How do I find my Y-intercepts?
Plug 0.
Plug 0 in for our x's. So I have 0 squared plus 5 times 0 plus 8 over 0 plus 3. So I have a Y-intercept at 8/3, which is between which two numbers?
2 and 3.
Thank you. So I'm going to write as an ordered pair. It's 0, 8 over 3. Let's talk about wholes, please.
There are none.
How do you know?
Because the top isn't factorable.
Correct. Once we get the hang of this, it's not bad. Can't factor anything. There's no common factors to cross out. So your answer here would be no holes. But we're doing this one because I want you guys to see how to graph with a slant asymptote. So let's draw what we know. On our graph, I'm going to put, let me use darker colors. I have a vertical asymptote at -3, correct? So
Yes.
The
I'm listening.
horizontal asymptote is none, right?
Correct. All right, there's my vertical asymptote. Now we're going to graph a slant asymptote. My slant asymptote was at x plus 2. So look, that means my intercept is at 2. What's the slope of y equals
Slope
x
is
plus 2?
one.
1 over 1.
Oh.
So 1 over 1. So again, we're going to have a dashed or dotted line, however you want to say it.
Dash.
Okay.
And put in your Y-intercept.
Okay, so now I have a region right here. Does everybody see the yellow region? Okay, then I have a purple region. Then I have a, we'll call this reddish pink. And then like a nice pretty mint green. Okay, do you see those 4 regions?
Yes.
We're gonna have funny looking boomerangs there. It's just, it's like taking your normal vertical and horizontal asymptotes. The horizontal just kind of shifts a little bit, so it's gonna smush our boomerangs a little bit. Do I have a Y-intercept that I can graph, that I can plot the point?
8/3, which is a little above, like, 2.
It's a little above 2, so it's like here-ish?
Yeah.
Okay, so if I have an intercept there, what do you know that the graph must do here?
There should be like a boomerang.
It should
there.
exist here. So you're gonna draw your boomerang in that little area. So it's just gonna be like our normal boomerang, but it's gonna just be like smushed up a little bit.
What type of boomerang is that?
It's a smushed up one. That's how they say it in pre-calc math terms. It's a smushed up boomerang. Right? Like if I took that dotted pink line and lowered it out to be horizontal, that boomerang would just come and it would look like a normal one. Now, some of you are going to say, well, then I know that the other boomerang is going to be in the opposite direction, whatever, you want to look at it that way. I want you guys to pick a point. Pick a point to the left, just like we always do, the left of our vertical asymptote. What's a point to the left? -5, okay? So let's plug in -5. See what we get out. So f of -5. What was my function again? X squared plus 5x. So -5 squared plus 5 times -5 plus 8 over -5 plus 3. Yeah.
Yeah.
Okay, so let's simplify. That gives me 25, right? Guys? Minus 25 plus 8 over -2. Agreed? Okay, so
Yes.
25s cancel out. I have 8 over -2, so I get -4. So when I plug in 5, I get out -4. So if I look at my graph, and I were to plot that point or figure out where that point is of -5, 1, 2, 3, -4, do you see how it exists down here in this region?
Yes.
So that means that's where my other boomerang is. It's just a smushed looking boomerang.
That's a weird boomerang.
I know, Deanna. Quit picking on my boomerangs. But look at that. Is that not the prettiest thing you guys have ever seen me do? I know.
Color coding.
Mr. Yurko doesn't know. Like, usually I do this and they're like, what? And where are you writing? Like, I'm all over the place. So this is good. But do you guys see what your graph will look like when you have a slant asymptote? Okay.
Yes.
Color coding is good. I appreciate it.
No problem. Anything for you, kiddo. All right,
I
so
used
tomorrow.
color coding.
Oh, I'm sorry. Go ahead.
I used color coding on mine too.
That's very helpful. So tomorrow I will have 2 more examples that'll be a little different, but hopefully you guys will feel a little better as we go through it, and then you'll be ready for your test on Thursday. Yes? Okay, I'm going to stop recording.